All right, so crisscrossing polyatomics continued. So we started doing a little bit of this the other day. So I think I gave you a couple of examples, but I don't know that it was as exhaustive as it could have been. So, like, for instance, I gave you things like, I think we did, like, the formula that forms between magnesium and nitrate. Right, so I told you that if you wanted to come up with a formula for these things, you do the same thing that we were doing before if we were just dealing with the elements and not these polyatomic things that have more than one atom in them. You just write the ions that form with their charges. So magnesium, you know, is 2+. Over the weekend, you're going to learn that nitrate has the formula NO3 1-. And when you want to crisscross these things with these polyatomic ions, the first thing that you have to do is maybe draw some parentheses around the polyatomic, just to help you out, just to help you visualize this. And the polyatomic ion is this thing right here that has more than one element in it. So I'm going to draw some parentheses around it, and then you crisscross. All right, so again, that number that is the charge on the magnesium becomes the subscript on the nitrate. The number that is the charge on the nitrate becomes a subscript on the magnesium. And so in this case, it would be Mg1, because you'll need one magnesium because of that charge, right? But I don't necessarily have to write the 1 there, it's understood. And then I would need 2 nitrates, so you put nitrate in parentheses with a 2 on the outside. You keep the parentheses if the final formula has more than one polyatomic. Right, so like for instance here we needed 2 nitrates, 2 whole nitrates, so you keep the parentheses because there are plural polyatomics that you have in the final answer. Yeah, Sean? Because you lose all structural information when you do that. Okay, here, I'm sorry, I didn't realize that was off the screen. Let me center it a little bit better. But I don't know, let me say that again. So you do not, technically speaking, mathematically, when we go to balance equations later on, you're going to have to realize that that 2 outside means that you have 6 oxygens and 2 nitrogens, but you don't actually distribute that number into the formula. So you would never write MgN2O6. You lose structural information when you do that. I don't want to get into that just right now. Probably later on in the year I'll explain to you what the difference is. Okay. All right, now, what if we had an example, so this was example number, like A, right? Let's do another one. So what if we had something like aluminum and phosphate? I think that was one of the final examples that we were doing, but I rushed through it. Right, so you would write aluminum with its charge, which is 3+, and phosphate with its charge, which is 3-. So again, we draw the phosphate in parentheses. We crisscross, right? So we would end up with Al3PO4 3. And again, what were we supposed to do to these formulas at the end after we're done crisscrossing? So the third step, what do we do to these numbers out here? You reduce them. So you reduce subscripts outside of parentheses. All right, so these are both divisible by 3, so when you go to reduce, then the final formula becomes Al1, right? PO4 1. You only need 1 of each of those. And technically speaking, do you really need to put parentheses around the PO4? No. How come? Because if you only have a singular polyatomic ion, you just don't need them. So the way that you would really see this written on a label would be AlPO4. All right? Now, as I mentioned, you could go through this whole process of crisscrossing and reducing, but there's a much quicker way of doing that with much less work. And so one thing to consider is that if the charges on your 2 ions are the same magnitude but different signs, what do we do? They cancel, right? If they're the same magnitude but opposing signs. And so if they're the same magnitude, right, so these are both a value of 3, but they're opposite signs and they cancel, what do we do to the letters? You just shove the letters together. So that's a shortcut. All right, so just shove the letters together to get the final answer. So let's do like one more kind of like that. So what if we had calcium and sulfate? All right, so what is the symbol for calcium? Ca2 plus. And then what's sulfate? You guys have a piece of paper in front of you where you can simply look it up, right? So it's SO4 2 minus. All right, so what do you notice about the charges up here? There's 2 plus and 2 minus, so then what do we do with those letters? They cancel. And so do we have to go through the whole process of crisscrossing and reducing? The answer is no. Just shove all the letters together. So the final formula would be CaSO4. Okay? All right? Do I do a couple more? Or do you think you've beaten this horse dead? Have we beaten it dead? Okay. All right, so let's talk for a moment then about what polyatomic ions are. So what are polyatomic ions? All right, so you guys, when we memorized all those ions off the periodic table, we were studying monoatomic ions. What does the prefix mono mean? There's one. So like, for instance, in O2 minus, there's only one kind of element in it. All right? So what about in NO3 1 minus? What do we have? Let me draw a picture of nitrate for you. So nitrate has nitrogen, oxygen, 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 right? Single bond between. Let me do a little bit of math here in the corner. This is something that eventually you'll learn how to do. Plus 18, plus 1, minus 24, minus 6. Okay, this is what nitrate looks like. Here. You don't have to know how to draw these. Okay, I'm just drawing it for you. So nitrate, these are ions this is a polyatomic ion. So the definition for polyatomic, if you think about the prefix poly, what does that mean? Many atoms. These are ions that exist in nature that have many atoms. And by many, I mean like more than one type of element in them. In nitrate, what do you have? You have 1 nitrogen and how many oxygens? 3. And the overall charge of the whole thing is -1. That's what that number in the corner denotes, is the charge of all 4 of these atoms put together. Yeah, Sean? You don't have to worry about that. I'll teach you at the end of the year. I'm not teaching you how to draw these yet. We're not there yet. Right now, I just want you to memorize that NO3 1 minus is called nitrate, period. All right? Later on in the year, I'll show you how to draw it. Okay? I'm just drawing it for you now so you can kind of visualize what this formula, like a different representation of this formula. Okay? All right, so then it kind of gets back to the question that you had a second ago, right? So if you had this formula, for instance, MgNO32, like why don't you rewrite this as MgN2O6? All right, why don't we do that? You don't see that they're bonded, right? So like if you were to distribute that out, you wouldn't know that in the real formula you have 3 oxygens for every 1 nitrogen. So let me draw what this looks like. So magnesium nitrate basically would be one of these ions, a magnesium in the middle with a charge of 2 plus, and then another one of those nitrates on the other side. So if you look at the formula, and you look at the like what we would draw, like if we draw a mechanism, right? What's the ratio of nitrates to magnesium? There's how many nitrates for every one magnesium? 2 to 1. So you leave that number there to show you the ratios, right? There's 2 nitrates for every 1 magnesium. If you were to distribute that number out, you no longer see the ratios that would show up in the formula. Does that kind of make sense? So that's why you don't distribute them. All right, so the polyatomic ions are, for right now, things whose names and formulas you memorize. And so let me grab the sheet and put it under the document cam. There's a slightly different table on eCampus. I would rather you just memorize this one. I decided that rather than having you memorize that one, I'll go with whatever Ms. Ansero was doing upstairs so that we stay consistent. But there's a lot of polyatomic ions, and for right now, I just want you to memorize the most common ones. All right? So the most common ones are things like ammonium, hydronium, acetate, hypochlorite, chlorite, chlorate, so on and so forth. The ones I want you to memorize off this table are the ones in bold. Okay? And as we mentioned before, I only need you to memorize the bolded name, not the secondary name that's in italics after it. Okay? Say what? No, I won't. No, I'm going to call it by its primary name. So, if you notice the charges on these polyatomic ions, by and large, most of them have what sign? They're negative, right? There's very few of them. There's only 2 of them that are positive, right? And the formulas that you need to memorize are here in the middle. So what I need you to be able to do is, if I tell you on a piece of paper, tell me what the formula for ammonium is, what I need you to do is to be able to produce this formula. So ammonium, hydronium, acetate, and acetate I would prefer for you to learn it this way. So maybe you guys should take out a highlighter and kind of highlight what I'm highlighting on my reference chart. Hypochlorite. I think there's a little typo here on the chlorite. What did they do here? I'm going to have to tell Ms. Dancer about that. Where's the charge? That sign, should it be subscripted? No, that charge should really be up here, should be superscripted. I wish I had whiteout, but I don't. All right, so that's a formula you need to memorize. Chlorate, perchlorate, nitrite, nitrate, cyanide, hydroxide. Let's see. Carbonate, sulfate, sulfite, chromate, phosphate, phosphate. Okay? So anything that's in bold is a formula and a name that you have to memorize. So flat out memorize. So what does that entail? Quizlet's good. I can find a Quizlet to put up on eCampus. Flashcards could help it. I'm going to be honest with you. When I tried using flashcards as a kid, they never worked for me. Yeah, Victor? You like that? Yeah, I don't know that you memorize things. I hate to break it to you, but this is good old-fashioned, like, elbow grease. When I was the most effective thing to memorize these things is not going to be the most fun thing, all right? So let's start with ammonium. So this is what I would do. I would take either a white dry erase board or a piece of paper, and there's something magical that happens, right, when you put pen to paper, all right? I want you to write it over again 10 times, and as you're writing it again 10 times out loud, you are verbally saying ammonium, NH4+, ammonium, NH4+, ammonium, NH4+. So come on, all together, grab a piece of paper. Ammonium, start writing. Ammonium, NH4+, ammonium, NH4+, ammonium. Sean, don't resist. Resistance is futile. You will be assimilated. Ammonium, NH4+, ammonium, NH4+. Okay, you get the hang of it? All right, so then we're going to go to the next one. Hydronium. H3O plus. Hydronium. H3O plus. Hydronium. Okay. What's ammonium? Cover it up. NH4 plus. What's hydronium? So this is what I would do, is I would sit and I would write it 10 times. I would have a partner sitting next to me, and then maybe every 5, have them quiz you. And then have them quiz you like numerous times and change the order of these things every time. I wouldn't sit down and memorize them all in one sitting. I would do 5, at one time, and then take a break for a while, come back an hour later, have someone quiz me on those 5, and then do the next 5, take a break, come back to the rest. Okay? Don't ever sit down and memorize this kind of stuff in all in one sitting. That's not good. You want to be able to get it into your long-term memory. All right? So that means that you're just going to have to do it in little bite-sized pieces. All right. So, not the most fun thing to do, and I apologize. All right? So, there is a way to I don't want to use the word cheat because it's not really cheating, but there is a mnemonic device that we can use that will get us at least, I want to say 12 of these without really doing a whole lot of work. You want to learn that way? Yeah. Okay. All right, so why don't we learn that way, and then maybe we can go back on this list and see what's left after we learn that little phrase that I'm going to teach you. All right, so let's put this in the notes. All right, so after you go through this process of trying to memorize these things, the other thing that you could use, a mnemonic device that will get you a bunch of these polyatomics without having to do a whole lot of work, is the following sentence. It's kind of a silly sentence. It's Nick. Remember like those sentences that you used to have to memorize that would tell you what all the metric prefixes were? What is that stupid sentence? Like kiss, King Henry VIII, drank, dirty, I don't know, something with chocolate milk. What about the one in biology to teach you like the taxonomy, like kiss Philip on the cheek or forget going steady, right? So kingdom, phylum, class. Did you ever remember that one? All right, so this is kind of like that. So this is a cute little trick though. So this is Nick the camel. 8. I'm going to put the number 1. Clam in, oh no, hang on. For supper in Phoenix on top of crates. It's a ridiculous sentence, but it's magical what this does. All right, so if you look at the polyatomic ions, look at the names. And let's ignore the ones that have the plus charges. Let's look at the names for like the things that are all negative. There's a ton of negatively charged polyatomics, right? Look at what all those names end in. Hypochlorite, chlorite, chlorate, perchlorate, nitrite, nitrate. Well, let's skip those two. Carbonate, sulfate, sulfite, chromate, phosphate, phosphate. So what do they end in? Iterate. Okay. So this little sentence is going to help you figure out pretty much 1, 2, 3, 4, 5, 6 of those things whose names end in 8. All right? Yes. Victor.
Well, what about the hypo and the third?
I'm getting there. Let me start slow, man. Baby steps. All right, so which ones am I talking about? So I'm talking about all the ones that end in 8 that include the element nitrogen, carbon, chlorine, sulfur, phosphorus, and chromium. So let's write these down. Nitrogen, carbon, chlorine, sulfur, phosphorus, and chromium. So I'm talking about nitrate, carbonate, chlorate, sulfate, phosphate, and chromate. All right? We're going to start with these 6 and then we'll expand. from these 6. All right, so if you look up the formulas on the handout, right? And you don't have to look at just those 6. What's the second element that's consistently present in the bulk of those formulas? Oxygen, right? So oxygen, 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 oxygen. There's one exception. But then the rest of them, the second element's oxygen, right? So let's go ahead and put in O, 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 O behind all of those initial elements that we wrote down on that list. All right, so now what I have to tell you is that this is an encrypted sentence. There is information hidden in these words, okay? For you to be able to decrypt that sentence, you have to be able to count consonants and vowels, right? So what are vowels? A, E, I, O, U. What are consonants? Not that. All right. Okay, so let's take a look here at the word Nick, all right? Start by counting the consonants. How many consonants do you see in the word Nick? 1, 2, 3. That's the number that you put on the oxygen. All right? How many vowels do you see? 1. That's the charge. And all of these were negative, right? So it's NO3 1 minus. That's nitrate. All right? So again, the little number down here is the number of consonants in the word. The number up there is the number of vowels. Okay, so let's see if you can produce the formula for carbonate. So look at the word camel. How many consonants are there in the word camel? 3 consonants, so that's the number that goes underneath the oxygen. How many vowels do you see? 2. All right, so what's the charge on carbonate? 2 minus. What about in the word clam? How many consonants do you see? 3 consonants. So that's a 3 on the oxygen. How many vowels do you see? 1. So the charge on chlorate is 1 minus. All right, what about in the word supper? How many consonants do you see? 4. How many vowels do you see? 2. So the formula for sulfate is SO4 2 minus. How about phosphate? The word phoenix. Now here's the problem. Some people can't spell phoenix, right? So you're going to have to learn how to spell that. So how many consonants do you see in the word phoenix? There's 4. How many vowels do you see in the word phoenix? 3. So the formula for phosphate becomes PO4 3 minus. And what about chromate? We have 4 consonants and how many vowels? Okay, there you go. There's 6 of the 17 that you have to memorize. Yes, ma'am? There is a guy who sat down and came up with this silly sentence. Right? Now, okay, but thank goodness that they did, right? Because I didn't really want to sit there with a dry erase board and have to write say ammonium NH4 plus 10 times, right? So now, let's go back to the sheet. Because I want you to see what is the difference between nitrate and nitrite, and chlorate and chlorite, and sulfate and sulfite. Yeah, Victor?
The I is less than the 8.
What do you mean it's less than the 8?
It has like less oxygen.
How many less oxygens? 1 less oxygen.
And the hypo has 3 less.
Oh, don't go there. Just the difference between 9 and 8. So it's 1 less oxygen. Does the charge change? Or do they keep the same charge? The charge is the same. All right, so look. So I promised you more than 6 out of the sentence, right? So here's some other ones. All right, so what if you wanted to figure out the formula for nitrite, or chlorite, or sulfite, or phosphite? I am. I skipped carbonite, because that only exists in Star Wars, right? That's what Han Solo was frozen in, was carbonite. It doesn't exist in nature. And I didn't put chromite, because that doesn't exist either. What if I wanted to figure out those formulas? So for nitrite, chlorite, sulfite, and phosphite. So what did we just say? Ide is 1 less oxygen. So what's 1 less oxygen from over here? NO2. And what do we say about the charge? Doesn't change, it's the same. Nitrite is NO2 1 minus. What about chlorite? What is it? ClO2, what's the charge on it? 1 minus. What's sulfite? SO3, what's the charge on it? 2 minus. And then what's phosphite? PO3, what's the charge on it? Okay, all right, we're up to 10. 10 of 17, good? Yeah, let's get 2 more out. I promised you 12, right? And per, bingo. All right, so we just did chlorate, which had the formula of ClO3 minus, and we did chlorite, which was 1 hydrogen, one oxygen less. All right, so let's get hypochlorite out of it, and then let's go get perchlorate out of this. All right, so what does the prefix hypo mean? Like hypodermic needle. Like what is what's a hypodermic needle? It's a needle that goes right underneath your skin, right? So hypo means 1 less. So hypochlorite means 1 less than chlorite. 1 less what? What are we playing with? The oxygen count. Now, does the charge change? No, it remains the same. So what's 1 less oxygen than ClO2 1 minus? ClO minus. All right? What about per? Per means 1 more. So 1 more than chlorate would lead what formula? ClO4. And does the charge change? There you go. There's 12 of the 17. So that means that you really only have to like pull up your sleeves and put some elbow grease into memorizing 5 of them. So let's identify which 5 you have to memorize. So if we go to the sheet, let's see. You can. You totally can. All right, so next Monday, first thing you're going to have is a quiz on these polyatomic ions. You can certainly flip the paper over, write that sentence down, but the key here is that you have to know how to read it, okay? All right, so was ammonium on this list? Okay, so I'm going to highlight it with a different color because that's definitely one that you're going to have to work on. How about hydroxide? Was it on this list? I'm sorry, hydronium. No, that's definitely one you're going to have to work on. What about acetate? Was that on this list? No, so that's definitely one you're going to have to work on. All right, hypochlorite we just did, chlorite we just did, chlorate we just did, perchlorate, nitrite, nitrate, cyanide. Was that on the list? We're going to have to work on that. Okay? What about hydroxide? No, definitely one you're going to have to work on. We did do carbonate, sulfate, sulfite, chromate, phosphate, phosphate, right? So it's really only those 5 that you're going to have to really work on. Okay? Yes, sir. No. The ones that we have highlighted here is all that I need you to know for the year. But now here's the issue. This isn't something that I want you to memorize just for the quizzes next week and then to forget. You're not allowed to forget any of this stuff until May. All right? This naming is not something that we're just doing now for this unit and then it's gone. It's going to be necessary. It's going to build. Okay? Questions? All right, so let me go ahead and stop the recording. We'll turn the lights on because some of you guys are having a tough time here. You do?